All right, welcome to today's webinar, where we will be talking about going from rapid prototyping to robust vision AI deployments. Just a few announcements before we begin. I'd like to thank those of you who've already submitted some questions. For those of you who haven't, feel free to submit questions at any time by clicking on the Q&A section of your Zoom portal. We also recommend using headphones for clear broadcast, and the webinar will be recorded and will be emailed to everyone afterwards. I am Carl Palme, the VP of Product at Neurala, and I'll be your host for today. I am joined by my colleague, Abhishek Gaur, who is a research scientist here at Neurala. Hello, Abhishek.
Hey, Carl.
So we're very excited about today's webinar because the content is really good, but we're doubly excited because we have we've launched the product today, and that is Brain Builder. It's a SaaS platform that, along with our proprietary lifelong DNN technology, allows AI beginners and experts alike to create custom vision AI solutions that solve business problems faster, less expensively, and on a secure platform. With a lot less data and without requiring special hardware, anyone can build a robust, deployable AI solution using nothing but a personal computer. Try it out today for free. You can sign up at www.neurala.com. All right, now on to the webinar. Today's agenda, we're going to try to cover going from rapid prototyping to robust vision AI deployments. We're going to try to cover things like the challenges with creating custom vision AI, the importance of prototyping in vision AI challenges, and the use case, and we're going to go through some use case examples. We're going to leave a few minutes at the end to go through some questions. The audience for today's webinar should be anybody involved in the product development process for robotics, drones, smart devices, or industrial applications, and who likely have cameras for differentiation or mission-critical processes. The questions that we hope to answer today are: what is challenging about developing custom vision AI, and why even do it? How to differentiate or innovate with vision AI? Why prototyping is so important for the development of vision AI, how to reduce risk, is it better to make or buy a solution, and what are the things that you should be thinking about when starting such a project? So why is creating custom vision AI so challenging, and why is it important to prototype quickly? Abhishek?
So if you look at artificial intelligence, or just the state of artificial intelligence in today's time, it's mostly dependent on this thing called deep learning, and which is this set of algorithms that learn from the lot of data that you present to it, right? So unlike your traditional software development, the thing that differentiates deep learning is that you cannot predict the outcome from the onset of the project. Like, it's very dependent on how what data you present to it, what kind of training regime it goes through, and then also it's very dependent on the kind of use case you're working from. And it basically consists of like 5 major steps that we have on the slides, with one of which is data collection and tagging. Then you have training, wherein you also do validation and testing within that. Then you have the optimization in order to make it run on a certain hardware, and then you have the final deployment. And each step can take anywhere from a week to 2 to 3 months, or even more, depending on what kind of problem you're trying to solve. And so right from the beginning, as soon as you have a problem that you think can be solved by AI, it requires a lot of deep dive into thinking what kind of data you would need, which sort of controls what kind of AI you would get at the end. So right from the onset of the project, you're spending too much time trying to collect this data. Every single step influences the next step in progression. So in order for you to be able to do everything in time, it becomes very important that you rapidly prototype and you fail early. Because if you spend 3 months trying to create an AI and fail right at the end, you would have to start all over again, right? Probably from your data step itself, which will cost you a lot and would have wasted a lot of human hours. So, and like 3 of the main reasons where I think why it is so important to rapidly prototype in AI is because deep learning, even though it's just more is just a set of mathematics that goes behind the algorithms. It's still more of an art than science, because these deep learning models, they operate in like high dimensions that we humans can't even visualize, right? So in that case, it's very hard for you to predict how your algorithm will how your algorithm will perform at the end of your once you're done with the project. And there are a lot of interesting ideas for particular problems that are out there in the research community, but there's no single solution that fits all of them. So you have to sort of pick these pieces, figure out which one of those work for you, and then piece them together and hope that all of this works once you have everything tied together. And that takes a lot of time, and time is money, because like I said, every step can take from anywhere from 2 days to 2 weeks or 2 months. And you would have to spend a lot of time in possibly manually tagging your data, or you would have to pay your engineers and research scientists to sort of write these algorithms and like optimize them to run on certain hardwares. And the problem with taking too much time is that you miss the opportunity to get to the market quickly. And that's important because people want it now. Like no one wants to wait 2 years for you to give them a product that that is required right now. So, and since it's a time-taking process, and most of the deep learning projects are very iterative, wherein you present a solution and then over time you sort of work towards making it better by more training and more, or just modifying your algorithms furthermore. So yeah, like these are the 3 steps why rapidly prototyping AI is very important from an end user's perspective, and also from the perspective of someone like me who's a research scientist who's trying to get these models out there in the deployment environments.
Great. So let's talk about some of the use cases. We obviously have a lot of customers. We've gone through a lot of these use cases, solved a lot of these problems for them. Let's start with the drone use case. So one of the problems that we hear is that people would like to use drones for inspection of power lines or cell phone towers, for example. Abhishek, why is this a good application for vision AI?
So, like the primary reason why something like a drone inspection use case is good for AI is because what happens as of today is you have this person or a human sitting there for 24 hours and just looking at images of the drone footage and then trying to figure out if there is a defect somewhere, or if you're just keeping an inventory. And if you look at these use cases, there's always some particular component involved which has a very specific and very consistent label associated with it. So all you're trying to do is you're trying to look at an image and you're trying to associate it with a label. This is something which AI is really good at. It can do it way faster than the humans. It can do it at a much higher accuracy. And that's sort of the reason why. And it also takes away the human who can now be involved in like more in some process that requires more of a human input. So that sort of reduces the time that you would spend in doing this work, and will also do it way more efficiently.
And so one of the questions that always comes up is whether the inference is going to happen on the drone or in the cloud. What are the trade-offs? What should our customers be thinking when they consider this question?
Right. And I guess this is one of the major questions that every customer who's dealing with a drone use case should think about, because the answer to this can sort of make a lot of difference at every step involved in the process, from data tagging to training to testing to deployment, every step. And ideally, you want to minimize all of these, right? So say if you're trying to build a system that needs to run in real time, right? If you run the system on the cloud, you need to factor in the time that you would have to spend in transferring the data from your drone to this server that is sitting somewhere, running the model on the server, doing all the processing, and then hearing back from the server for an answer. Now, in terms of the design of the model itself, and since there is some extra time involved in the data transfer, you might want to write a model that is super fast or just does an inference at a really quick rate, so that you don't spend a lot of time in the processing of the data once you've gotten it. And that could potentially mean that your model might not be as accurate. Like, it's a generic norm that bigger models or deeper models are more accurate, but they're also very slow. But at the same time, if you if you want to run this model or if you want to run this inference locally on the drone, you end up saving the time you would spend in data transfer, which means that you can now have a model which has a higher capacity and it can take slightly longer to do the inference, but is also more accurate. Now that said, it also comes down to the point where your target hardware might just not be capable enough, or an embedded hardware might not be capable enough to run inference in real time. But just in 2018, there have been so many chips and like so many vendors out there that have created processors to run these models at a very high speed. So real-time inference is something becoming ubiquitous, and you should be able to find hardware that can run this.
So in essence, it comes down to what, making a trade-off between accuracy, speed, or cost.
Right, exactly.
Another question that comes up is whether the drone will be flying during the day or night or both. What are the things that we should consider in these cases?
I mean, this question is crucial at so many levels, right? From the data collection to model creation. Because if you know that your drone is only going to operate during the day, you don't really need to collect the data set for images for night, right? You know that it's only going to look at this cell tower during the daylight. Similarly, if your model, so in order to tackle such situations, you might have to add some sort of pre-processing and post-processing. And knowing beforehand in what your deployment environment is can sort of help you reduce the time and cost related to these steps. Because if it's going to run at night, you need to take care of the factor that the hardware itself should be good enough that it gives you images. You might need an infrared camera or something. And the problem with that is once you're using an infrared camera, it gives you great images at night, but you end up losing a lot of features that sort of define that object. So in order, you need to sort of tackle that when you're creating the model itself. So answering these questions in the beginning and like having some idea of your deployment engine and like your deployment environment can help you save a lot of time in the later stages of the project.
All right. And so if we were to give our listeners one tip, what would that be?
Well, one of the things is that drone images are aerial, right? And you won't really find a lot of data online that's open source that look like the drone images. So if you're working for a use case that involves drones, ideally all your images should be taken from a drone, or your footage should be from a drone. Otherwise, if you train on images, which is a mix and match of images from a drone and like ground level images, your model performance is most likely to get hurt. So you should be careful about that.
Excellent. All right, let's move on to our next use case, where we have a customer who wants to create an application that runs on a mobile phone, and it'll help their users identify a certain type of disease on plants. Why is this a good application for Vision AI?
Well, again, you have a system wherein there is an image and you're trying to find certain kinds of defects. Now, this is a classical, this is another sort of research area which is very popular in deep learning, which is called anomaly detection. Because this is not something that your system, you cannot really define what a certain type of disease might look like from the beginning. Like you might have some defining features, but assuming that it has, they would never have some like a consistent pattern, which tells you that this is an anomaly. So an anomaly detection is something that AI again is really good at. So that's part of the reason why this is again a good Vision AI application.
Great. One of the questions that always comes up when we talk about app development and Vision AI is how much battery can I let this neural network eat? Why is this important?
I mean, it's pretty obvious because neural networks are very computationally intensive, right? These are the systems that take up a lot of your battery and can also require a lot of memory to run at times. So when you know that your target hardware is sort of running on a mobile, you should be aware of all these things, and you should design your model from ground up in a way that it has lesser number of parameters. It shouldn't take too many flops to run. So if you consider these things, it would help you in the end, wherein you won't have a model that runs for 5 minutes and drains the entire battery of the phone.
Okay. And obviously, because these are handheld devices, there may be some damage on the phone. Right. And so one of the questions that also comes up is, can neural networks handle cases where the camera lens is dirty or scratched?
Right, and this is another thing that is easily overlooked when you design such systems, because our intent when we create data is to create the data that is perfect. Like, or we want to create data which is very close to our use case, but at the same time, we always try to collect images which are high quality, which would give a good idea of what an object looks like. We want the features to be very visible. The problem with that is that you sort of make your model learn only about how things look when the environment is good. Like once you have a blemish or a scratch on your camera, and say it's an expensive equipment that you just can't replace because there's a scratch on it, you need to make sure that you're doing some sort of pre-processing or post-processing that handles such cases.
Great. So understanding obviously that data is important, and obviously these handheld devices are gonna, we need to consider their battery and just how they're gonna be used. What additional tip can we give our listeners when they're thinking about app development or smart devices and Vision AI?
Right. So I think few of the key things that matter when it comes to running stuff on mobile is that how much inference time it will take for the model to run, how much memory consumption will happen, how much battery is it consuming, or what's the user experience like. Now, if you look at it, none of this is related to the actual performance of the model. Like these are the things that you can test out before even training a model. So one of the good ways to deal with it is you create prototypes of models that you intend to train, but even before training them, just run them on some dummy data, create the model architecture, and run it on the end device and get all these statistics. And once you have shortlisted some of the models that fit all these constraints, that's when you start training, because training can take very long and you don't want to encounter these issues at the end of training process.
Great. All right, so let's move on to the next use case. This is more in the industrial space. In this case, the problem is our customer wants to create an inspection mechanism to help understand things like poor soldering of components or poor adhesive application. Why is this a good application for Vision AI?
This again goes back to this is very similar to the case that we discussed just in the previous slide, that this is a classic case of anomaly detection in vision. And again, AI can do it much better. It has been proven to do this much better than humans can.
Great. So one of the questions that comes up when we think about industrial applications is how critical is the accuracy?
Well, this depends on the use. This usually depends on the use case, right? Because if you're deploying this system on, say, a car assembly line to make sure that the paint job is consistent throughout the car, you can probably get away with a model with slightly less accuracy or slightly less precision, or you could still afford a few false positives. I'm not saying that you should create a model that's not as accurate as you want it to be, but at least this use case is not life-threatening. On the other hand, if you're going to use this AI to make sure that the airbags in the car are not defected, the margin for error becomes really less. So you want to make sure that based on your use case, your entire workflow supports the target metric that you have in your mind for at the end of the project.
Great. Another question that often comes up with industrial applications is what kind of hardware should our customers be speccing out?
Right. So usually in industrial cases, people just assume that they would have a big servers and they can just run stuff on big servers, which is sort of an overkill. And that's again dependent on the use case. If you know that this, like I said, if it was the first case wherein you want a model that just tries to figure out the consistency of the paint job, you possibly don't need a very high capacity model, because all you're trying to do is just making sure that the pattern that you're looking at is consistent. So that can be done by a model that does not require an 8 GPU cluster. Whereas on the other hand, if you're trying to do defects, you want a model that is as accurate as possible. You might want to run an ensemble of 10 different models together. And for that, you might need a server with 16 GPUs or 32 GPUs running together. So knowing your metrics and knowing your use case thoroughly can help you save a lot of money in terms of the money that you would invest in the hardware.
Excellent. And again, as with the other use cases, What would be a tip that we would like to give our listeners when they're thinking about these types of applications in the industrial settings?
Right. So one of the great things about most of the industrial processes is that they are very consistent, or they are sort of static. That is, and by that I mean that the deployment environment is usually very static, and there are chances that a camera is always looking at a particular object from a same angle every time. Like it doesn't, like the point of view of your input might not change at all, right? So this is something that you can leverage very well while creating the models. And like when you're creating a data set, you can only have the images collected from that point of view, because you know that the camera would never move from this position, or it will always look at the product from this particular angle.
Great. So, I mean, I guess concluding all of these use cases, it seems like building a robust vision system or solution can really benefit from understanding what are the problems that our customers are trying to solve, what are their target metrics, what are the trade-offs that can be done, and obviously they benefit from prototyping early. So today there exist technologies that allow you to prototype and deploy with less images, less annotation time, and less expertise. This means faster and less expensive deployments. Brain Builder is one such tool. So just talking about our announcement today and going a little bit into what the interface looks like, let's talk about the example where we're trying to do a inspection system for sheet metal. And we want to understand things that don't have these defining features that, for example, traditional vision systems would be very good at. With Brain Builder, it's easy to see how the brain is being built and how well it is performing with every single image that you tag. In this case, on the top right corner, you can see with those power bars how well the system is already predicting with every single image how well the system is performing at that one point. In addition, we provide you with statistics that give you the accuracy, what additional classes need data, and how each class is performing in the model. Because everything is vision related, we also give you the validation set so that you can understand what images are the true positives versus the false positives, so you can understand what are the patterns that are confusing the model, and of course you can improve it. And one of the most important things, as we've been talking about this, is prototyping, iterating, and improving the model. And the nice thing about Brain Builder is that we can help you with every stage of the development. You can deploy a model in production and then have one in staging so that you can test on some machines, but not deploy massively across all of your devices or all of your machines, while at the same time continuously improve the model that you have in Brain Builder. So we're announcing Brain Builder today. It's the fastest, easiest, least expensive vision AI. Try it now for free at www.neurala.com. Now, we have a few minutes for questions. So let me take a look at the questions that we've received, and let's take a look here. All right, so one of the questions that we have is, can we get links to the slides? Yes, we will be returning, we will be sharing this webinar, the recording with everybody after this session, absolutely. Do you have any, let's see here. Another question that we received is, how can we make up for small data sets? Abhishek, what are your thoughts on this?
Well, particularly, I mean, this is something that we have tried to tackle in Brain Builder, and this is what sort of LDNN, this is a classic case at which LDNN is really good at. Now, LDNN is your traditional, isn't like your traditional DNN, and it can in fact run on like create models with less amount of data, and that's the whole point of it. So the way we, this is sort of a problem that we can help you solve. Apart from that, when it comes to the classic cases where you don't have a lot of images, the best strategy is to actually collect more data. At the same time, there are a lot of solutions or a lot of research solutions that are available online that sort of handle the cases of underrepresented classes, or when creating models with less amount of data, or data augmentation strategies. You can also do things like create synthetic data and use that to train alongside the data that you already have, which is the real world.
Great. And just to put a plug in there for Brain Builder again, one of the nice things about lifelong DNN is that you can create models with even a very small data set.
Exactly.
So that's good to keep in mind. We have another question about data annotation and whether we can export the data and what formats we support when exporting the data for creating models outside of Brain Builder.
So as of today, we support Caffe and TensorFlow. And so the idea is that we would give you, you can get your tag data set in a format that will be easily ingestible in either TensorFlow or Caffe, based on which framework you're using.
All right. Another question that we have is whether Brain Builder is a cloud-based solution or on-prem or both. The answer is currently it is a cloud-based solution. We are working on an on-prem solution that we hope to have by the end of the year. And we hope to have a lot more features as we roll out the rest of the roadmap for the year. And to follow up that question is, if it is a cloud-based solution, how may I actually use the model? And the answer is you deploy the model on the cloud, and then via API calls, you can ping it and get inference values back. But again, we will also be deploying an SDK so that you can deploy your models on mobile devices and computers shortly. Here's another interesting question, Abhishek. Are we incorporating LiDAR or range-based data as input for training classifiers?
This is something that we have on the roadmap, but it doesn't support it as of today. As of today, it can only work on 2D images or videos. It can actually even train pretty well on, you can upload a video tag, use our video annotator to just tag one frame and then train a model based on the tags that it generates from the rest of the remaining video, which is like a 15-minute process.
All right, well, it seems like we're running out of time. The best thing that I can recommend for everybody is if you're interested in seeing whether Brain Builder works for you or not, I would recommend going into Neurala.com, signing up. And like I said, the service is free right now, and you can upload your data and you can start training a model, and you should know very shortly whether this is going to work for you or not. We are very excited about this release, and we look forward to getting all of your feedback. So thank you everybody for attending today, and we hope you have a nice rest of your day.